Hi everyone, this is an example of a solution stoichiometry problem. Like always, we're following our same 4 stoichiometry steps with extra emphasis on the interpretation and more options to choose from as we work our way through this question. Here we go. What is the concentration of sulfuric acid if 1.50 liters of it reacts with 2.65 liters of 0.150 mole per liter sodium hydroxide? Our first step is to determine what the balanced equation is. We might need to focus in on a key word or a key phrase. Reacts with. Because now we're seeing questions that are starting to have as many as 3 numbers in them, it becomes maybe an important strategy to reread the question and skip the numbers. What is the concentration of sulfuric acid if it reacts with sodium hydroxide? What this question is telling us is sulfuric acid reacts with sodium hydroxide. Let's get that down. Sulfuric acid is H2SO4. We can find it in the data booklet on the acid table. Reacts with sodium hydroxide, sodium 1 plus, hydroxide 1 minus. Questions about solution stoichiometry don't have to be about acids and bases. They could be about regular ionic solutions. It just so happens that this one is again a neutralization reaction. We have a double replacement reaction. The sodium and the hydrogen switch spots. The sodium, which is a 1 plus, gets together with the sulfate, a 2 minus, and the hydrogen 1 plus and the hydroxide 1 minus. Now we balance this reaction like so. Each side 2 hydrogens, 1 sulfate on either side, 2 sodiums, and 2 hydroxides on either side. We have a balanced chemical reaction. Let's take it slow. What is the concentration of the sulfuric acid? Pretty explicit. Here's the sulfuric acid, H2SO4. What is the concentration of it? Concentration, we don't know. We're trying to find out. If 1.50 liters of it, that it right there means the sulfuric acid. So the volume here is 1.50 liters. It flashes through my mind already, even maybe on my very first reading, that these volumes need to be in liters, and the question gave us liters twice. What a relief, we don't have a unit conversion. Whatever that question mark is, that's R. It's required. What else do we have? Oh, here's our standard way of having this expressed to us, volume of concentration chemical. That links those 3 things all together. Here's the sodium hydroxide. We have the volume and its concentration. The volume right here, 2.65 liters, and the concentration, 0.150 moles per liter. We're still getting used to those units, moles per liter. Those are the standard units for molar concentration. We have our interpretation. This is the G, by the way. We've balanced our equation. We've interpreted the question. Our next step, let's find moles. Reading, mass over molar mass, clearly not. All we have are C's and V's. We have to find moles by doing C times V. But this C and V must belong to the same chemical. Here we don't know the concentration. We're not using those values first. C times V. Concentration is 0.150 moles per liter. The volume, 2.65 liters. Big reminder that volume must be in liters. This question gave us it in liters. What a relief. Be on the lookout for those times where you have to do the unit conversion yourself. Next step, multiply by the R over G. R over G comes next. R over G, 1 over 2. R over G, 1 over 2. All that work, our preliminary work, and the R over G all collectively, we've been calling red N. Red N. In the end here, what we're looking for is concentration. Let's look at our step 4. Moles, mass, concentration. What is it? Red N divided by volume. This is all the red N, so we're going to divide by volume to find the concentration. Let's divide by the volume. Here it is, 1.50 liters. If we're looking for the concentration in the end, we must use the volume that goes there. Or we can't use this same volume twice. That wouldn't make sense. We have our calculation set up. We can get to pushing buttons. 0.15 times 2.65 multiplied by 1 over 2 divided by 1.5. We have the answer on my calculator screen. 0.1325. That's the raw answer on our calculator screen. We need to think about significant digits. The numbers in the question here all have 3 significant digits, so we must round our answer off appropriately. Rounds up to 0.133, and finally, we need units. This is the concentration. We're not exactly used to it yet, but the units for concentration, moles per liter. We're following the same 4 steps as ever. We have more options to choose from, so the interpretation, being very clear what's being given to you and what you're being asked to do, is important. As always, whatever we're doing first in combination with the R over G, that's always going to represent this red N. Our earlier work and the R over G leads us to red N, which we can use appropriately. Sometimes we might be multiplying by the molar mass to find the mass. Here, because we were looking for the concentration, our last step was divide by volume. So here we can see divide by that volume right there. Take your time with it, do your best, and I hope this helps.